Hello everyone and welcome back to another trigonometry video. In this video we are going to focus on polar equations and polar form of points. So we're used to graphing things in terms of x's and y's. And we call that rectangular form. So here's our x-axis and our y-axis, and we know if we want to graph any point, we start at the origin and we move left or right, and then up or down. And then it takes both of those movements to graph one point. In polar form, we can think about things in terms of the polar axis and the pole. The polar axis is going to line up with this positive x-axis, and the pole is what we would call the origin in the xy plane. So when we graph polar equations, we're thinking about really things in terms of a circle. So we're thinking about what is the radius and what is our theta value. So polar coordinate planes look something like this. Okay, I'm going to zoom in on this a little bit. So we're thinking about things again in terms of circles. If we were to label this, this would be 0 and pi. So we would have pi over 2 here, and then we would have 3 pi over 2 down here. And you can see these major points, major lines here are lining up with pi over 6, so 30 degrees, 2 pi over 6, which is pi over 3, and then we could go around the circle and label all of these. So just like in rectangular form, where we have two movements, move along the x and move along the y, we're going to have the same thing in polar form, only we're going to be thinking about moving theta, and then we're going to move along the radius. So theta is going to be the angle from the polar axis out, and then our r is going to tell us which way we move. If r is positive, we're going to move along the terminal side of the angle. If r is negative, we're going to extend that terminal side and move along that. So let's look at a few examples. Let's start with that first one. I'm going to go back to my coordinate system here. Number 22, we're looking at graphing 5 and 5 pi over 3. So I'm going to go through and I'm going to label the rest of my points here. So I've got pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. And then I'm going to go through and I'm going to label my pi over 4s. So pi over 4 would live along this line. So we have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 lines up there, 5 pi over 4 is right here, 6 pi over 4, and 7 pi over 4. That way we have everything labeled and it's going to be really easy for us to figure everything out. So that first point is 5 pi over 3. So you always start with theta. So 5 pi over 3 is down here. So my angle is going this way. This is my terminal side. And because r is positive, we're going to move along that terminal side 5 units. So we're going to move. Here's 1, 2, 3, 4, and 5. So there's the point 5 pi over 3. This is problem 22. Let's look at another one. Let's look at number 25. 25, we're looking at 4, negative 2 pi over 3. So we're going backwards with theta because theta is negative. So we're going to go negative 2 pi over 3. So negative 2 pi over 3 would be here, and this is my terminal side, right? So we're going to move along that terminal side because our R value is positive. And we're going to move 4 units, 1, 2, 3, 4. So there's my point for number 25. So let's look at 27. 27 is the point negative 1, negative pi over 3. Okay, our negative angle means we're going backwards. So negative pi over 3 would be here. So here's my terminal side, but because our R value is negative, we're not moving along the terminal side. We're moving along the opposite side of the terminal side. So if we were to extend that terminal side out, we're moving along this path. We're going to move 1 unit. So our point's going to be right there. Trace these extra lines. This is the point for number 27. And then let's do one more. Let's look at 30. It's negative 3, negative pi over 2. So we're going to move negative pi over 2. Negative pi over 2 would be here. So my terminal side would be this side, but because R is negative, we move along the opposite. So we extend that terminal side in the opposite direction. And we're going to move 3 units. So 1, 2, 3, right here. There's my point for 30. I'm going to clean my graph up by erasing those extra lines. So what's really interesting about polar form is that for a point, there's not one unique way to write it. If we were in rectangular form, let's think about the point 2, 3 again. So we know the point 2, 3 would have lived here. That's the only way I could describe that point if I'm talking about rectangular form where I'm talking about an x-coordinate and a y-coordinate. But because of the nature of trigonometry and those circles and theta values, there's lots and lots of different ways I could end up at this one point if I'm thinking about things in terms of r and theta. Because I could think about that theta value as 0, or I could think about it as 2 pi, or I could think about it as negative 2 pi, and so on. There's an infinite number of ways that I could write theta, and because there's an infinite number of ways I can write theta, there's a lot of ways I could think about what r would have to be to get me to the point I need to be in. So let's look at an example where we can take a point and we can write it in 3 different formats. I'm going to do 37. So it's going to help if we were to draw a picture of where this point lives. And I'm not going to pull out the graph paper for this one. I'm just going to draw a rough sketch on a rough sketch of the paper right here, of the point right here. So remember, this is our R value and our theta value. Theta is negative pi over 4. Negative pi over 4 would be this angle. But because R is negative, we are moving along the opposite side of the terminal side. We're moving 3 units along that way. So that point actually lives right here. So in part A, they're asking us to make R positive, but they want theta to be a negative value between negative 2 pi and 0. Well, if R is positive, then we have to have this as 3. The question is, what are we going to do with theta? And how are we going to force theta to be in here? Well, right now we're at negative pi over 4. If R is positive, we need to move along the terminal side. So we would actually need this angle right here. So it's going to be negative pi over 4, and then we're going to move another 180 degrees in the negative direction, or a negative pi in the negative direction. So that's going to be negative 5 pi over 4. B is asking us to produce a theta value that's between 0 and 2 pi, but they want R to be negative. Well, if they want R to be negative, we have no choice but use a negative 3 here. Since we want r to be negative, we know we got to move along the side that's opposite of the terminal side, but we still need to end up at this point here in that second quadrant. So to move along the side opposite of the terminal side, we need this theta value here. So to find that theta value, we're going to take 2 pi, because that would be all the way around, but we're going to subtract pi over 4. So that's going to be 8 pi over 4 minus pi over 4 is 7 pi over 4. And then let's look at C. C, we want r to be positive, but we want theta to be between 2 pi and 4 pi. If r is positive, we know we're going to have a 3 for that. And we want to go around the circle one time and then a little bit more. So what's going to go on with our picture here? Let me see if I can erase some of the stuff that I've already done. Clean my picture up a little bit. So we want to go around the circle a full time. So that's 2 pi. And then again, this much. So we got to figure out how much that is. So we're going to take 2 pi and we're going to add pi over 2 and then add pi over 4. So pi over 2 came from this piece here, and pi over 4 would be this piece here. So we have 8 pi. Well, let's turn everything into pi over 4. So 8 pi over 4 plus 2 pi over 4 plus pi over 4 would be 11 pi over 4. So there's our angle, 11 pi over 4. So a lot of this really comes from, let's draw a picture and see where this lives. What would we need to force these restrictions to happen? Do I move along the terminal side, or do I move along the side opposite of the terminal side? And then figuring out what your theta value is going to be.